Hi everyone. In this session, we are going to discuss extraction of metal part 3. If you didn't watch part 1 and part 2, watch that video, then you can come to this video. The topics which we are going to cover in this session are extraction of metals at the top of activity series, electrolysis, extraction of sodium. These topics we are going to cover in this session. Let's start the discussion. Extraction of metals at the top of activity series. What is activity series? Activity series is the arrangement of metals according to the reactivity. On the basis of reactivity, there is an arrangement of metals. This arrangement is known as activity series. It is our activity series. This activity series is classified into three groups. First group is most reactive element, more reactive element. Second group is least reactive element. Third group is moderately reactive element. Here we are going to discuss extraction of metals which are present at the top of activity series. So here these are the metals which are present at the top of activity series: potassium, sodium, calcium, magnesium, aluminium. These metals are highly reactive. Here we are going to discuss the extraction of sodium. Extraction of sodium. We have done a lot of discussion on extraction. The zinc is extracting from the ore zinc sulfide. First we are converting zinc sulfide into zinc oxide, and zinc oxide undergoing reduction to form zinc. Mercuric sulfide, cinnabar is the ore of mercury, and mercuric sulfide is converting into mercuric oxide, and we are reducing it to form mercury. Everywhere the reduction process is common. First we are converting that ore into oxide and we are reducing it. If we are converting the sodium into sodium oxide, it will be the sodium oxide Na2O, that is Na, 2 sodium atom and 1 oxygen atom, that is Na2O. Here the sodium is having strong affinity towards oxygen, so reduction is not possible. Here this sodium atom, there are 2 sodium atoms here and 1 oxygen atom. These 2 sodiums are having strong affinity towards oxygen, so separation is very difficult. So reduction is not applicable in this case. Reduction using carbon, reduction using aluminium, these methods are not applicable in this case. We cannot use reduction method using carbon or other reducing agents because sodium is having strong affinity towards oxygen. We are going to use another method. That method is known as electrolytic reduction. How can we extract sodium from its ore? Here we are going to use a new method. That method is known as electrolytic reduction. This topic is very important. From this session you can expect one or two questions for your board exam. Before that, you should understand about electrolysis. Here there is a container. In this container we are taking any electrolyte. It is an electrolyte. Electrolytes are the substance which can dissociate into ions. AB is the electrolyte, then there will be A plus and B minus. CD is the electrolyte and there will be C plus and D minus. NaCl is an electrolyte, there will be Na plus and Cl minus. Here we are considering an electrolyte. It is an electrolyte. We are going to arrange 2 electrodes here. There are 2 electrodes now which is made up of carbon or any other metal. We are connecting these 2 electrodes to the cell. So this one is positive electrode, this one is negative electrode. We know that electrolytes are the substance which can dissociate into ions, which means in electrolyte there will be ions. So here there are 2 types of ion, positive ion and negative ion. Here we can see the positive ion and negative ion. This electrode is positive and this electrode is negative. What is going to happen here? The positive ions are going to move towards negative electrode and negative ions are going to move towards positive electrode. Let's see that there will be a separation of ions. The ions are separating because of the oppositely charged electrode. This process is known as electrolysis. So electrolysis is the separation of charges because of electricity. Now we can define electrolysis. The positive electrode is known as anode and negative electrode is known as cathode. Electrolysis. It is a process of separation of ions of an electrolyte when electricity is passing through it. When electricity is passing through an electrolyte, it will separate, the ions will separate. This process is known as electrolysis. Now we can discuss electrolytic reduction. How we can extract sodium from its ore? The answer is we are separating sodium from sodium chloride. We are not converting sodium into sodium oxide. Instead of that, we are taking sodium chloride. From sodium chloride, we are going to separate sodium. The method is electrolytic reduction. For that, we are arranging a container. It is a container, and in this container, we are taking sodium chloride. It is not a normal sodium chloride. It is molten sodium chloride. We are melting sodium chloride. So it is molten sodium chloride, NaCl, molten NaCl. And we are arranging 2 electrodes. There are 2 electrodes now. one is positive and one is negative. We are connecting this electrode to the cell. This is the arrangement. Now this one is negative electrode because it is connected to the negative terminal of the cell. This one is positive electrode because this electrode is positive electrode because it is connected to the positive terminal of the cell. So we can write it is anode and this one is cathode. Anode is having positive charge and cathode is having negative charge. And it is molten NaCl. Molten NaCl means there will be ions Na plus and Cl minus. There are ions Na plus and Cl minus. Here you can see the ions. This one is anode, positive charge. This one is cathode, negative charge. What will be the change in the electrolyte? What is going to happen here? Because you can see here there are Na plus and Cl minus ion, opposite charged ions. What is going to happen to these ions? Yes, the ions are going to separate because of opposite charged electrode. This one is anode. All the negative ions are going to shift towards anode and all the positive ions are going to shift to cathode. So negative ions are going to shift to anode and positive ions are going to shift to cathode. Positive ions are going to shift to negative electrode and negative ions are going to shift to positive electrodes. Here you can see that. Now the ions are separating. All the positive ions, Na plus, all the Na plus ions are depositing at cathode and all the Cl minus ions are depositing at anode. So in anode and cathode there are some reactions. We need to write the reaction. In the exam you need to write the reaction as well as you need to draw this diagram. We are going to write the reaction. Which ion was shifting to cathode? The ion was Na plus, right? So here it is Na plus. If Na plus is reaching here it is anode. If the Na plus is reaching here, Na plus is going to accept one electron from cathode. Cathode means it is negative sign. It can donate electron. Na plus is going to accept one electron to become Na. Na plus, what is the reason for plus charge? There is a deficiency of one electron. One electron is less. So when that Na plus is accepting one electron from cathode, it is going to become Na. So here Na plus plus E gives Na. That's a reaction. And in anode Cl minus is shifting towards anode. Cl minus is having a negative sign because there is an extra electron. Cl minus is going to leave that electron, liberate that electron to form Cl. So it will be Cl minus give Cl plus electron. Cl is a diatomic molecule. Diatomic means two atoms. In a molecule there are two atoms. So Cl plus Cl gives Cl2. These are the reactions taking place in cathode and anode. You need to learn that. And here there is a small change in the definition of reduction. Reduction is removal of oxygen, isn't it? Here reduction is addition of electrons. Anode or cathode, which side reduction is going on? In which side reduction is taking place? Yes, cathode. There is an addition of electron. So in cathode reduction, in anode oxidation. So here we can write reduction, here we can write oxidation. This method is known as electrolytic reduction. In cathode, we are getting sodium. Sodium is obtained from electrolytic reduction of molten sodium chloride. At anode, Cl minus gives Cl plus electron, Cl plus Cl gives Cl2. Cathode, Na plus electron gives Na. If you like this video, please subscribe to my channel. Visit our website www.winpointonlineclasses.com. Support us for providing free online classes to everyone. Thanks for watching.